thought that maybe it would be a good idea to create a video showing you how to do some of these lab tasks. Maybe that would help some people who are struggling with some of the concepts in the course. So I'm going to start with lab 6, and if we look at question 1, it says improve the MOD server that we wrote last week and basically create threads out of this. So you would have one class which would be your main thread, and that would create the server socket, listen for incoming connections and deal with them, and eventually start the communication thread which would actually communicate with the with each client that connects to the server. And then we'd have a separate class called communication thread where the actual communication would take place. So if you remember, the idea behind an MOD server is very simple, that it simply prints out a message every time a client connects to it. So let's try and get started. I'll actually do this from scratch so that everybody can follow through. Right, so let's say this is lab 6, and we're going to create a new class, and we're going to call this our MOD. So, okay, so I should have picked where's this project explorer? There we go. Okay, so lab 6, I have to create a new class, and we're going to call this MOD server. So here we have our new class, which would be the main MOD server, listening for incoming connections and doing everything that a server needs to do. So what are the basic elements of a server? Well, of course, we'll need a main method. We would need to create server sockets to listen for to create server sockets and reserve a port for the server to run. We need to start listening to incoming connections. Once we get a connection, we deal with the client, and this is generally in the form of writing to the client and reading from the client, right? Depends on what you really need to do in this case. Okay, so the signature of the main method looks like this: public static void main string array args. Now the signature of the main method has to be exactly the same, so up to here it has to exactly match the way I have written it. The name of the arguments array can differ, so it would be no problem if you call this A or any other name, but generally due to the way standards are written, this is actually called args. Okay, so now that we have our main method, we need to create and reserve our server socket for us. So how do we do this in Java? So we first say server socket, and then we give this a name, server, let's call the server socket equals to new server socket, and as a parameter we want to pass in which port we want to listen on. So anything higher than 1024 should be fine, but in this case we want to do 9999 just to be safe. You will notice that Eclipse is complaining that there are some issues. It basically tells you what the problem is. It tells you that it cannot understand what server socket is, and it offers a solution, which is import server socket from the java.net package. So if we now did a import java.net.star, we would have imported all the classes under the .net package, and that should solve this problem. Now that solves that problem, but Eclipse is still now complaining on the right hand side. It now says that this is unhandled exception. Basically what it means is that when you're trying to reserve a socket or a port, there might be issues with reservation, right? So if another program is already using that port, you cannot reserve that port for yourself. Hence, your Java program will actually throw an exception. So it's asking you to try and catch this exception. So we all know how to do that. So we will say try, and we will put our code in the try block, and because we have try, we need to catch, and in this case we know that it's going to throw a IO exception, so we can say IO exception E, and then inside the catch block you can say e dot print stack trace, so that it actually prints if something goes wrong during the process. So there's no more complaining. You would, however, see this yellow line, which is not a compiler issue, but it's simply a warning. So Eclipse is trying to tell you that you've created this value and you haven't used it. So have you forgotten to use it? But in this case, we haven't done it, so it's fine. Okay, so once we have this reserved for us, we now should start listening for incoming connections. How do we do that? We do that using the method on the server socket class. So we take the reference for our server socket that we have created and we say accept. Now if you remember, this is a blocking method, which means the server will actually wait on this line and listen for incoming connections on that port. What happens is, as soon as an incoming connection request is made, the server actually goes through your computer, finds a free port on which the server can communicate with that client, and returns it back to you so that you know which port it is, and then you can start doing things with it. So what it returns to you is a socket for this connection that it has just created. So whenever we accept something, incoming connection, it will return back to your socket. So we're going to store this in client socket so that we can then use this to communicate with our client. Okay, so at this point in line 14, you have already connected, you've already been listening to incoming connections, and a client has requested something. So a connection has been accepted and the server has returned a code to you, a socket port number to you, saying this is where the client is now connected. You go ahead if you want to communicate with it. So in this case, we want to communicate with the client, and because this is our MOD server, what we really want to do is send a message back to the client. So how would we do that? To connect to a server, to connect to a client and actually write something down the socket, we need to have a print writer which allows us to write things into a socket. So we want to create our print writer, pw equals to new print writer, and we want to connect this print writer to this client socket's output stream, because we want to send data down that socket so that it gets to the client from the server. So we would say client socket dot get output stream, and that's it. This would give us a print writer. So the first thing is, you will see Java is now complaining about this line. It says it does not understand what's print writer, and as we know, print writer is part of the Java IO class library. So we will say import java.io.star, and that would actually import print writer into the code, and voila, there are no problems anymore. However, if you remember, we talked about flushing. Whenever you're using print writer, you will actually try and automatically buffer the data that you're sending, and because this is a network connection, we want to, in this instance, we want to send data as soon as we write to the socket. So if you put a second parameter here, which is true, it turns auto flushing on, which basically means every time you write something to this socket connection, it will send the data down through the stream to the client. So now that we have our print writer, we are free to write whatever we need back to the client. So we can say pw.println, and then we're going to say, hello client, you have connected to my MOD server. Have a good day. Good day. And that's it. So what we have done is, we are reserving a server socket for us. We are listening for incoming connections. As soon as an incoming connection happens, we get a client socket back. We are creating a print writer on top of the client socket's output stream, and we are turning auto flushing on so that we can send data as soon as we write to it. And once we have this print writer, we can write anything to it just as we would to a file. In this case, this is a whole string, and it would push it through. Once you're done with that, it's good idea and it's good practice to close everything down so that you don't waste resources. So in this case, we are done. So we're going to say print writer close, and we can also say socket dot, client socket, client socket dot close, And that's it. We have closed everything down. If you also want, you can close down the server socket, but we'll see in a second why we don't want to do that. Anyways, so this is now done. I should now be able to run my server, and there's no outputs, but from this red button you can see that the server is running. I didn't write anything to the console, so I can't see. So maybe it's a good idea to say some outputs for you to see on the server side so that you know things are going right. So you can, at this point, you can say port 9999 reserved successfully, right? And at this point we want to say waiting for incoming connection. At this point we want to say, oh sorry, so we are actually waiting for incoming connection before this line. At this point we have already had a connection established to the client, right? And at this point we want to say created print writer, and then at this point we want to say we have already sent the message to the client, and then we want to say closed everything down. So we want to say we have closed all server resources. There we go. Okay, so now if we run this, we can see that port 999 was successfully reserved by the server. We are waiting for incoming connection. So let's set up a connection. So in my case, I can do telnet, the port number, and the the IP address, and then the port number. So this should create, this is like a client. It could be from anywhere as long as you get the IP address right. It would connect to my machine and on this port number and connect to the server eventually. So if I enter, watch here, first of all it says creating established connection. So connection established, somebody actually connected to us, and then I created the print writer, message to the client was sent, and then I closed all the server resources. And if I look on the client, you will see that the client actually received that message back, and then I closed the server on this end. So this was the MOD server, which I think is pretty simple. But as you can see here, as soon as one of the client has been served, we actually shut down the server. But we don't really want to do that. What we want to do is we want to serve clients again and again and again, because that's what a server really does. So what we really want to do is we want to wrap all this code, right, which is waiting for incoming connection, to actually servicing the client, right, which is up to here, in a loop so that we can do this again and again. So if we now say while true, which is basically an infinite loop, right, so that keeps on looping again and again, we now will reserve a port, wait for incoming connections, accept connections, serve that client, and then close that particular connection and move on to the next bit again. So there is one problem that I have made because of this, which is basically now that we have this infinite loop here, right, we will never actually close the server, and we don't really want to close the server down because we want the server to keep on running forever and ever and then serve clients. So this code is now pretty useless. So we just cut that bit out and have the same code again. So what's the difference now? Now the difference is I can have one client connect to it, it finishes dealing with that client, right, and it goes back to listening again. Then I have another client connect to it, it finishes with that client, goes back to listening again. But what it cannot do is it cannot serve multiple clients at the same time, because as you can tell, a client connection is accepted, and then it goes through this entire process of responding to the client and then goes back to listening for another client. Now the problem with this is if we actually have a huge amount of stuff that we're doing here, right? Now, in this case, it probably wouldn't be a problem because we're just sending one line back and computers are very fast. But if you did a lot of processing, or imagine if this was the ecosystem where the server was actually talking to the client, right, and was waiting for input from the client through the keyboard and so on, other clients would actually be in a queue waiting for connection to the client server. So we don't really want to do that. What we really want to do is we want to use threads. So if you remember, Java programs always have a main thread. So the main method starts the main thread, and everything we have been doing so far was inside the main thread. So if we could now source out all this work that we're doing, so what we will do is this work that we are doing, which is this part, right? Actually creating a print writer and sending information to the client. Now that could be any information that we wanted to, or any kind of communication that we wanted to. But the idea would be that all this stuff which is dealing with the client, right, is dealt with by a thread. So each client, when they connect, get their own thread, and this part which deals with that client goes in its own thread. And the main thread job would only be to listen for new incoming connections and send that information through to the threads. So if we take this concept on, and now we say we're going to have something called a communication thread, right? So how do we create a thread? The first thing we have to do is we have to say extends thread. That essentially makes this class inherit all the properties of a thread from the thread class. And because this is now a thread, it has to have a method called public void run. This is the method that gets run when you actually call the start on a thread. Okay, so inside this, what do we really want to do? So we want to outsource all this work that we have been doing for the client to that thread. So we take this out from here. So we actually want this work to be done inside the run method when we call the run method. Now notice, as soon as we do this, everything is fine, except it doesn't understand what a client socket is, because there's no declaration of a client socket. So the idea would be, when a client connects, the main thread would listen for incoming, would accept the connection, find a socket on which the client and the server can communicate, and send the information about this socket to the thread that it creates. And then that thread will take care of whatever it needs to do with the client. And the main thread goes back to listening for new incoming connection. So how would we actually pass this socket information to a thread? Well, we know, forget that this is a thread, we know that when we create an object, we can have a constructor for a class where we can send it information. So to communicate with the client that wants to communicate with, this thread actually needs a socket. And let's call that client socket so that we don't have to change any code. And of course, Eclipse is going to complain because it doesn't know what a socket is, so we need to import socket. Now we introduce a constructor in this. How do you write a constructor? You say public. Remember, constructors don't have a return type, so it's public and then the name of the class. So exactly the name of the class. So this is, oops, forgot to copy. So this is a constructor. And what we want to send it is the socket information. And once we send it that, we want to put that socket information inside this client socket variable. So now when we create an object of this class, we can set it a socket information that goes inside the client socket. And over here, when we run the when we call the start method on the thread, it will run this method, and it can use the client socket information to communicate. Notice now Java is complaining that there is no try catch block. Remember, we forgot, we actually kept the try catch block here because we were dealing with this stuff. So we also need a try catch block here to make sure that we catch any nasties that happen in this piece of code. So there we go, and we can now say catch IO exception. I think that is the only exception that can happen here. We'll check. Okay, there we go. Yeah. So now this thread is ready. As soon as you create an object of this thread, pass it a socket and start the thread, it's going to create a print stream to that socket and then write down stuff. Okay, so coming back here, what's our job? Our job would be that once we have established a connection to the client, we now create a new thread from our communication thread, and well, create a new object from our communication thread class and pass it the information about the client socket. So once you have done that, we need to start the thread and that's it. And then we can go back in the loop listening to new incoming connections. Okay, so how do you create an object of that class? Very simple. Communication thread, let's call it ct equals to new communication thread, and we pass it the socket information for this client, which is that. Once we have done that, all we need to do is start the thread. So we can say start. Notice, to start a thread, you always say start. You do not call the run method directly, right? It's the thread class that creates the magic that's needed to call this run method in its own thread. If you call the run method directly, it just becomes a method call. It won't be under a thread. Okay, so to make this more informative, let's just say let's start. Okay, so we'll, at this point we will say waiting for incoming connection, connection established. At this point we will say that I have created a thread created, and we will say thread started. And if we go into the thread class, we will see and say here that so we can say thread dot get, oops, okay, so we can say thread dot get, no, we can't do that. So I think we just have to say get name, yeah, because this is a thread, it automatically has a get name method which is inherited from the thread class, and that method would give you a name for this thread that's running. Hopefully that will be different from each thread that we create. So then we say thread, the name of the thread, plus sent message to client, and we'll say created print writer. Okay, so looking good. Now if you notice, my program was already running here, right? I never remembered to close the previous server that I wrote. So although I made all these changes, Java is still running server on that port. So if I now go back in this, it's actually still running the old class that I created and compiled. So if I now try and run this, and this is a common problem that many of the students have, if I try and run this, I'll actually get an error saying address already in use, because the previous server is already running. So before I do that, I need to close that server down. That actually releases that port number 9999, and then you can start your new program again. So now if I do this, it will say port 99 reserved and ready for you to connect to. Okay, let me clear this and try and connect again, and now you will see that I get the same output on this side. Doesn't matter, but on this side you see a bunch of other information. So you say that the main thread had created a thread, thread started, and then it went back listening for incoming connections, whereas thread 0 now went ahead and created a print writer and sent a message to the client, which means if I actually had multiple clients doing this at the same time, right, which is very hard to simulate here because of the small amount of time it takes just to write a string, but hopefully we can still see something. So this, for example, says thread 1 sent this, and with this one you see thread 2 sent this, right? So each connection now gets a new thread automatically, although we are using the same code. A better demonstration of this is, what if the communication thread, and this is actually I think question 2 or 3, which is a counting thread, I can't remember. Anyways, a better example would be, instead of sending this one line, right, what if I actually needed my server to send back many lines? So let's say 500,000 I plus plus. So I've just written a loop which counts from 0 to 500,000, and I'm going to print the numbers back to the client that it connects. So I'm going to restart my server. This time when I connect, I should get a print line. So I forgot to do print line. There you go. It was printing all the numbers on a single line. Okay, so go back. Right. Oh. So I think I actually managed to crash the terminal because of the huge amount of data it wrote. Let me see. Okay, that's not good. Okay, terminal, there we go, not responding. So the huge amount of data it wrote to the terminal actually crashed the terminal. As refusing. No, there we go. Okay, so now if we look at this, we will see that we get a lot of numbers back, and this is thread 0 writing a lot of stuff back. See, while thread 0 is writing that stuff back, I have another client which tries to connect, and now you see thread 0 and thread 1 and thread 2 are writing things together, and I could actually have another client, and you will see a slowdown, but you will hopefully see all 3 clients being served at the same time. Now remember, my hardware here is not really meant to be a server, so it doesn't work parallelly that well, but you can still see the sense of it. You can see all those 3 clients being communicated with at the same time, and over here you can see that 3, 4, 5 were being sent messages in parallel using threads, while the server is still running and listening for new incoming connections. So I hope that this code, right, I'm going to leave it here so that you can go back and see it if you need to. So this MOD server is like a standard piece of code where a server listens for incoming connection and passes that client socket information to a separate thread. And the thread is the specialist class which does whatever it needs to do with the client, meaning it communicates with the client, gets data, and sends data back. So the communication thread would at least have a class, a constructor where you would pass the client socket information to it, and then inside the run method you would do what you need to do. So if you so for example, when I replaced this with the loop, this became like a number server. If we had that line instead, it was a MOD server. If I replace those 2 lines with reading the information and then sending it back to the client, then it becomes an echo server, and so on. So yeah, that was it. Feel free to ask me any questions you have, and we can take it from there. Right? Cheers. Thanks.